Hi, we're Group 12 and today we'll be presenting to you the final video of L3 application. Our aim was to conceive, design, build and test a long-distance small jumping robot of less than 20 cm diameter and 30 grams. In order to get inspiration, we have decided to look at nature around us, and as you can see from our design, we have opted for the jumping mechanism of a grasshopper, where an extension spring was loaded, releasing energy to perform the jump. We predicted a 1 meter 27 centimeter jump at an angle of 45.8 degrees. The angle was calculated by looping a series of angles into a MATLAB optimization code and finding the maximum distance it will produce. The size of our robot was 7 cm with a weight of 20.72 grams. Since weight is one of our constraints, carbon fibers were used for sections under axial forces, whereas aluminium were used for sections experiencing bending. 3D printing was used to produce complex shapes such as the cams and the hinges, and Anger was our choice of printing material because it's the least brittle. Frames were laser cut using acetal because they're impact resistant and light. To reduce frictions, bearings were used to improve shaft rotations. As you can see from the video, our robot was able to jump 25 cm with charge manually, showing that the design was feasible and working. The electronics were working well as the motor was able to turn the gears when activated by remote control. Now the question is, did it jump on the day? Unfortunately, it did not, so let's have a look at the reasons behind it. The main issue we had was the shaft connecting the cam to the gears. As you can see, when the motor spins the gears, the cam does not spin. This problem occurred as the shaft couldn't be correctly fixed on the gear. Many attempts to glue and modify the shape of the shaft were made, but unfortunately they were all unsuccessful as glues were not strong enough and new parts were too small. Another issue we had was the gear misalignment, as gears could easily move on the shaft as said before. If we had to continue the project, we would choose different type of gears, such as metallic gears, in order to avoid shaft slippage and to make them more resistant to damage. Another alternative would be to go for thicker gears using the 3D printing. We initially considered both options, but they were too heavy and hard to buy from the market. Another way of tackling the problem would be to create a cap and cap it on the top of the gear to maintain its axis of rotation. To conclude, despite the fact that the robot did not jump, we saw that the mechanical design was successful as it could jump manually and the electronics were working. As we aimed for the smaller and lightest prototype, we took risk in manufacturing it, which impeded our jump. This is the end of our video. Thank you very much for listening to us.